ሰላም እንዴት ሰነበታችሁ? የኢትዮ ግራቪቲ ቲዩብ 12 ቻናል ተከታታዮች፣ እኔ አበራ ገብረ ሚካኤል እባላለሁ። ቻናሌን ሰብስክራይብ እና ሼር በማድረግ ለተለያዩ ሰዎች ማድረሳችሁን እንዳትረሱ። ዛሬ የምናየው ባለፈው ፕሮግራማችን ካየነው ርዕስ ስር ያሉ የተለያዩ የማትሪክ ጥያቄዎች እና የምዕራፉ መጨረሻ ያሉ ወሳኝ ጥያቄዎችን የምንሰራ ይሆናል። ተከታተሉን። End of unit questions and selected matrix exam from projectile motion የተመረጡ የማትሪክ ጥያቄዎችና ዩኒቱ መጨረሻ ላይ ጥያቄዎችን እንሰራለን። ቀጥታ ወደ ጥያቄዎቹ እንገባለን። Question number 1, the vertical component of velocity of the projectile at highest point of the trajectory is A maximum, B equal to the horizontal component of velocity, C 0, D changing direction. Horizontal component of velocity of the projectile at highest point in the projectile highest point ላይ ሲደርስ when object on the flight, the flight arrow is the highest point ላይ ሲደርስ ምንድን ነው ኦብጀክታችን የኦብጀክት ቬሎሲቲ vy becomes 0 እና the horizontal component of velocity throughout the motion is constant. Horizontal component of velocity throughout the flight constant ነው ዋጋ ያለው ነገር ግን vertical component ኦብጀክቱ highest point ላይ በሚደርስበት ሰዓት 0 ነው የሚሆነው እና ከዛ ዳይሬክሽን ላይ ይወጣል ማለት ነው። በዚህ ፍጥነቱን ከዚህ ጋር ሲወረወረ ወደ ወደዚህ ሙሉ እያደረገ እየቀነሰ እና እዚህ ጋር ያርፋል ማለት ነው። እዚህ ማክሰሙ ጋር ሲደርስ የኦብጀክት ቬሎሲቲ ቨርቲካል ኮምፖነንቱ 0 ይሆናል። vy is 0. So the correct answer is C. C is correct answer. When it comes to equation number 2, the following statement about the projectile motion is true. The projectile motion the horizontal and vertical motions are independent. Vertical and horizontal motion independent, and we discussed last time. We know that the horizontal component of velocity is called v naught x, and the vertical component is v naught y. So the object is shown with v naught. Object to v naught is whatever. Horizontal motion vertical motion independently handled the regular. This is true. The force on the projectile is constant throughout the flight. Throughout the flight, force is constant. That force is equal to force due to acceleration due to gravity. The gravity amount is the force no matter. Only force of it. Every direction, every position, it can be acting downward. Beyond the position of the object downward act when you come to C, so this one is correct. See right? The acceleration of the projectile is constant throughout the flight. So this is not the choice. Throughout the flight, acceleration is the same, which is gravity is equals to 9.8 meters per second square. This gravity is the same as the acceleration of the body. Acceleration is this also correct. When you come to D, the path depends on the initial velocity, but not upon the mass of the projectile. The path can be dependent on the initial velocity. Okay? When a body is thrown with initial velocity, with this v naught, the path of the projectile is depends on this initial velocity v naught. It's not dependent on the mass. So this is true also. E, all of the above statement is true. So the correct answer is E. E is correct answer. All above the statement is correct for this question. So D is correct answer. E is correct answer. In question number 3, when you come to question number 3, let us calculate now a range. The question says, a cannonball is fired at an angle of 45 degrees above the horizontal with an initial velocity of 30 meters per second. What's the range of the cannonball? A 30, B 60 meter, C 90 meter, D the 120 meters. So what is the given here? ምንድን የሰጠን ካርቦኑ በ45 ዲግሪ ፋይር ቢደረግ እና ኢኒሻል ቬሎሲቲ 30 ቢሆን ጊቨናችን ምን ይሆናል? given is we have an angle theta is 45 degree and the current body is thrown with an initial velocity of 30 meters per second. 30 meters per second, so we are going to detention. Then for gravity, let us assume that it is 10 meters per second square. So what's our formula to calculate the range? Solution, calculate the range. Range is equal to twice of v naught square sine of theta times cosine of theta over gravity formula. So it's directly equal to mass bottom. 2 times 30 meters per second whole square, then sine of 45 degree times sine of cosine of 45 degree over gravity 10 meters per second square. Gravity 10 meters per second square. So from this one, 2 times 900 meters square per second square times sine of 45 and the cos of 45 is the same, which is 0.707 times 0.707 over gravity 10 meters per second square. So these zeros cancel out, and then second square is cancelled by second square. When we make the square cut, 1 meter is cancelled by 1 meter. Then 2 times 90 is 180 times 0.707 times 0.707. So it is about 90 meters. So our answer is 90 meters. We multiply this number, it gives us 90 meters. So the correct answer is C for this question. Question number 3. C is the correct answer. And when you come to the next question, question number 4, an object is dropped from the cliff and another object is launched horizontally from the same height. Which statement is true? A, both objects will take the same height, the same time to hit the ground. B, the horizontal launched object will take longer to hit the ground. C, the vertical dropped object will hit the ground first. D, the horizontal launched object will hit the ground first. ሁለት ኦብጀክቶች ቢኖሩ አንደኛው ሆሪዞንታሊ ሆነ ከክሊፍ ላይ ቆሞ የሚኖረው ሌላኛው ደግሞ በሴም ሄይት ላይ ቆሞ ብታይ ሁለቱም ኦብጀክቶች መሬት ላይ ለመድረስ የሚፈጅባቸው ሰዓት እኩል ሰዓት ይፈጅባቸዋል። They take the same times. Both objects will take the same time to hit the ground የሚለው ትክክለኛ ሲሆናል። ሁለቱም ኦብጀክቶች the same time ይፈጅባቸዋል ከተወሩ እዚህ ለመድረስ እና ሌላኛው ኦብጀክት ደግሞ እዚህ ታች ላይ ለመድረስ የሚፈጅበት ታይም ሁለቱም So for question number 4, the correct answer is A. A is correct answer. And when we come to question number 5, a football is kicked with an initial velocity of 15 meters per second at an angle of 60 degrees above the horizontal. What's the time of flight for the footballs? Let's calculate now the time of flight for the football. For question number 5, we have given the calculate the time of flight. What are the given here? We have initial velocity v naught is 50 meters per second central, angle theta 60 degrees central, gravity 1 meter 10 meters per second square meter. Time of flight ማለት total time ኦብጀክት ቶሎ እስከሚወርድበት ድረስ ያለው time of flight ይባላል። ስለዚህ the time of flight or total time is equal to twice of v naught sine of theta over gravity and formula እንጠቀማለን. So 2 times 15 meters per second times sine of 60 degree over 10 meters per second square. So 2 times 15 is 30. So that's meters per second times sine of 60 degrees 0.866 over 10 meters per second square. 0 is cancelled by 0. So it is about 2.58. So the answer is 2.58 seconds is the correct answer for this question. And when we come to the question number 6, a baseball is thrown with an initial velocity of 25 meters per second at an angle of 30 degrees above the horizontal. Which statement? What's the horizontal component of velocity? What's the horizontal component of velocity here? calculate horizontal component of velocity, for question number 6, what are the given here? The given is V initial is given, which is 25 meters per second, and the angle theta is 30 degree. And angle theta is 30 degree. Gravity 10 meters per second square. So we have to calculate horizontal component V naught x. What's V naught x? V naught x is calculated by V naught times cosine of theta. These are formulas we discussed previously. Was it calculated in our so that's it, 25 meters per second times cosine of 30 degree. 25 meters per second times 0.8. 7 approximately. So it is about 21.75 meters per second is correct for question 6. Okay, now the next question is projectile is launched at an angle of 45 degrees above the horizontal. Which statement is true? Where the projectile is launched at an angle of 45 degrees above the horizontal, we know that the range is maximum. Range maximum what we discussed about that. When a projectile is launched about the 45 degrees from the horizontal, now the range should obtain the maximum range in the then the time of the flight will be the same as if it were launched vertically upward. Time minus 9. The range will be the maximum. The range will be maximum now. See, that's matter. The maximum height reached will be equal to the initial height. Correct. The horizontal velocity will be 0. Horizontal velocity 0. In every position constant. So the object performs the over the side. The horizontal distance maximum. Horizontal distance range maximum. I'm sorry, the Sarasa degree over object maybe the Z and the Z of በሰላሳ ዲግሪ ቢኖረው ሰርቲ ዲግሪ ያለው ቢኖረው ሊገባ ይችላል። በስልሳ ዲግሪ ቢኖረው ደግሞ ሜቢ ደስ የሚሆነው ይኖራቸዋል ይገናኛል። ነገር ግን በ45 ዲግሪ ከፍ ብለን ኦብጀክታችን እንዲኖረው ኦብጀክታችን ማክሲመም የሆነ ዲስታንስ የሚሄደው መቼ ነው? በ45 ዲግሪ ሲወረድ ነው ማለት ነው። እዚህ እስከዚህ ያለ ርቀት የሚጨምረው ማክሲመም ሊሆን የሚችለው በ45 ዲግሪ ሲወረድ ነው። ሶ when object is shown with 45 degree horizontal, the maximum range will be obtained. And the next question, assume that the ball is thrown horizontally from the building of the height h above the ground with the initial speed of v naught. Which one of the following statement is correct about the motion of the object? Assume object action thrown horizontally from the building height h object action horizontally let's say this is a building. The building actually the building is a common and then I have a what can be happening? A, it is horizontal component acceleration 0. Horizontal component of acceleration is 0. B, it is vertical component velocity remain constant. Vertical component of velocity remain constant. C, it is vertical component acceleration 0. Vertical component of acceleration 0. It is horizontal component velocity uniformly increasing. Let's see what's often under band image. Object or a good contour over the side with a good building like one, durable over. And then horizontal component of velocity throughout the flight constant over. Vertical component of velocity 0. Object or velocity. horizontal kick ማድረግ የሚጀምረው ምንድነው? vertical kick ማድረግ የሚጀምረው መቼ ነው? ልክ ኦብጀክቱ መውረድ ከጀመረ ማለት ነው። ይህ መውረድ ሲጀምር vertical ይሆናል። v naught x is the same as vx. v naught x is the same as vx also. v naught x is the same as vx. This shows that the horizontal component is constant throughout the flight, but the vertical becomes variable. vy1, vy2, vy3 varies throughout the flight. And when you consider the component of acceleration, when object comes from horizontal direction, and horizontal component of acceleration is 0, but there is a vertical component of acceleration. In every direction, in every position, the acceleration is acting downward. አክሰለሬሽን ዳውንዋርድ ነው አክት የሚያደርገው። ስለዚህ ሆሪዞንታል ኮምፖነንት ምን ማለት ነው? ሆሪዞንታል ዳይሬክሽን አክሰለሬሽን ብዙ ግራቪቲ አይኖርም። ወደ ጎን አይደለም ግራቪቲ የሚስበው አይደል? ግራቪቲ ወደ ታች ነው የሚስበው። አንድ ነገር እንዲህ ምን ወደ ታች ሊወርቅ የሚወርቀው ጀስት ግራቪቲ ወደ ታች ስለሚስበው። ስለዚህ ቨርቲካል ኮምፖነንት ኦፍ አክሰለሬሽን ይኖራል፣ ሆሪዞንታል ግን ዜሮ ነው። ስለዚህ multiple choice A ደግሞ horizontal component of acceleration is zero. Horizontal component of acceleration object to ወደ ጎን ሲወረወር ዜሮ ነው። ይሄ ልክ ነው። vertical component of velocity remain constant. vertical component of velocity remain constant ነው። vertical component ሞሬት ከጀመረበት ጊዜ ጀምሮ ምን ማለት ኮንስታንት ነው? ቫሪ ያደርጋል የሚለው እዚህ ጋር ዜሮ ነው። እንደን ከዛ ቫሪ ያደርጋል ሞሬት ሲጀምር። horizontal ግን ኮንስታንት ነው። It is vertical component of acceleration is zero. Vertical component of acceleration only is the vertical component of acceleration. Then it is horizontal component velocity uniformly increase. Horizontal component velocity uniformly increase. Okay. Constant on short side. Constant. So the correct answer is A. A is correct answer for this question. When we come to question number 9. Question number 9. A projectile is thrown from the level ground with an initial velocity v naught makes an angle theta above the horizontal. If the maximum height covered by the projectile is h, what is the horizontal range of the projectile in terms of h and theta? So we have given that the object is thrown with initial velocity v naught and object with an angle theta, and the maximum height can be given as h. So we have to calculate the range in terms of what? In terms of, let us calculate the range in terms of theta and height. Show Maragalan. So, here let us start. Merchant guide there again. Merchant Mujamara Kali Wara, where they are going to Vadan. Multiple choice A medulla h over tan theta, B h times tan theta over 4, C 4h over tan theta, D h over 4 tan theta. So, let's even search in terms of theta. So let us start from the formula of the maximum height. What's maximum height? V naught square sine square of theta over 2 times gravity. Okay, you have formula. Range is calculated by using twice of V naught square sine of theta and cosine of theta over gravity. So when we make the ratio of this one, h over r of the number, this side, V naught square sine square of theta over twice of gravity over twice of V naught square sine of theta and cosine of theta over gravity. And then to cancel the same terms, let us make the square part of this one. Here is square part of r. H over r and V naught square sine of theta sine square of theta sine theta and sine theta over 2 times gravity now. Then we have just going this one card g over gravity over twice of v naught square sine of theta and cosine of theta. So gravity, here we have gravity, and then we have gravity cancels out. Sine of theta is cancelled by sine theta. V naught square is cancelled by v naught square. So what's left now? H over r, which is equals to h over r is equals to sine of theta over 2 times 2, 4 times cos of theta. 4 times cos of theta. What's sine of theta over cos theta? Sine of theta over cos theta is tan theta. You know that. Tan of theta, which is equals to sine theta over cos of theta. So in terms of this one, it has been tan theta. H over r, which is equals to tan of theta over 4. ስለዚህ ሬንጅ ለማግኘት ሪያሬንጅ እናደርጋለን። ሪያሬንጅ ስናደርግ ሬንጅ is equals to h times 4 times h over tan theta ማለት ነው። ይሄ ከፈለጋችሁ ክሮስ መልቲፕላይ ማለት ይችላል። መጀመሪያ ክሮስ መልቲፕላይ ማግኘት እንችላለን። 4 times h which is equals to r times tan theta ነው። ኦኬ ስለዚህ ለtan theta ወሳኝ እናጥፋው ለtan theta ታንጀንት theta ስለዚህ ለtan theta እናጥፋው እንደሚቀረው እዚህ ላይ ቀራ ታንታ በታንታ ሲጣጣ አረጋለሁ። ስለዚህ አር ሬንጅ is equals to 4h over tan theta ነው ማለት ነው። መልሳችን። So the correct answer is C. So this is all about